So we're going to talk about lines that intersect inside of the circle and what that means for the angles that are formed at their intersection. So for our theorem 12-13, the measure of angle 1, where those two segments intersect, is equal to half the sum of the intercepted arcs. So half the sum of arc x and y. So it's kind of like we're taking the average of x and y to find that angle that they make. Then 12-14, so if the angle is outside the circle, we find the measure of angle 1 by subtracting. So we take half of the difference of our arcs. And it doesn't matter if we've got secants or tangents. If that angle is outside of the circle, we take half the difference of those intercepted arcs. So we got to decide, is it inside or outside, and then we're either adding or subtracting. It looks like for the first one, we're inside the circle. So that means we are going to find the sum, half the sum. So x is going to be half the sum of the intercepted arcs, so half of 46 plus 90. And we get 68. So the angle is going to be 68 degrees. Then for the next one, am I looking for those lines intersecting inside or outside the circle? It looks like it's outside. So if it's outside, what I'm going to use is that the angle is half the difference. So the angle is actually given to us. So 20 is actually equal to half the difference of our intercepted arcs. So 95 minus z. So we got to solve for z. We multiply both sides by 2 so that we can cancel out that half. So now we have 95 minus z equals 40. We'll subtract 95. And so z is 55. Okay, so you can also find the one of the intercepted arcs. You don't always have to be finding the angle inside or outside the circle. So we decide, is this inside? Is it meeting inside or outside? And it looks like we're meeting outside. So that means we're going to be finding our missing arc measure by using half x minus y. Another thing to look out for, this one's actually a special case, which we're going to talk about. One thing to note is that if we have a tangent and a tangent, so they only meet once here, these two angles are going to be supplementary. And we notice 110 plus 70, they're subs. So if you've got tangents here, they're always going to be supplementary. Also, these tangents intersect here. So that means that if this is 110, W is going to be 360 minus 110, because that's the other part of our circle that we have. So if it's a tangent, so a line that just intersects at one spot, right, one point, so these are tangents here, they break our circle into two parts and we can find each part. Now for D, this is not a tangent, right? Like it doesn't hit once, it hits the line twice. and it's also outside. So this angle y, is equal to half the difference of our intercepted arcs. So you get 40. So it depends on whether you're working inside or outside. It also depends on whether you have tangents that intersect at one point versus intersecting the circle at 2 points. Last two, we are looking at the lines intersecting inside the circle. So it's the sum one, it's the one where we add. And so it's the angle is 1/2 arc. So x plus y. So the angle, that middle angle, which is down 35, they gave us that part, is equal to half x plus 30. To get rid of that 1/2, we multiply by 2. So I multiply by 2, and I get x is 40 again. All right. And this one again, we're inside the circle, so this is the sum one where we add, and it's like arc, divide that by 2. Should give us x. X is equal to half arc plus arc. I get 126. And that's the first part of 12-4.